Good day to everyone. Our focus today is we are going to continue the basic differentiation rule in finding the derivative. Now, these rules are actually a shortcut method. Okay. Now, notice that we have been discussing the constant rule. We have the power rule, and we have the multiple constant rule. Now, the next thing that we're going to discuss would be the product rule. Okay, the product rule. So, what is the product rule? So, the product rule is actually defined by this notation. Okay, so our notation for the product rule is the derivative of the product of the function f function and g function will be the same as in here. It is the product of f function multiplied by the derivative of the g function. So meaning to say, we're going to get the derivative of the g function. So we have in here the g prime of x, and then added with its reverse, okay, the product of the original g function multiplied by the derivative of the f function. So we have in here the f prime of x. Okay. So that is the notation for the product rule. Now, to understand further the product rule, let's try to illustrate. We have in here at least 3 problems. So it says in here, what is the derivative of the product of these two? So y is equal to the quantity 2x raised to 4 minus 3 multiplied by the quantity x raised to 2 plus 1. Now notice that when we are going to apply the product rule, we have to identify, okay, we have to identify our multiplicants, okay. So our multiplicants in here, this first multiplicant is actually our f of x, okay. This is actually our f of x, and the other one is actually the g of x, okay. So g of x. So with this, after identifying the multiplicants of our problem, now that's the time we're going to apply. Okay, we will be applying this notation. But before we are going to apply this notation, notice that when we are talking of our addends, now notice that we need to have the derivative of our g of x. And what is the derivative of our g of x? That is g prime of x. So we will get the derivative of our g of x, which is the same as let's try to have. Okay, let's try to have. So for the g of x, that is defined to be x raised to 2 plus 1. So we will get the derivative one by one, and then after that one we will add them. Okay, so what is the derivative of this one? So the derivative is g prime of x. Okay, so what are we going to do? That is the same as we put this one again as the numerical coefficient of x. So we have 2x. Okay, we have 2x. Of course, this is the same as 2 minus 1. And what did we say about the derivative of the constant? The derivative of the constant is actually what? 0. Okay? So what is your g prime of x? The g prime of x is actually 2x raised to 1, or just 2x plus 0. And so the result will be, that is the same as we have now in here. Okay? G prime of x is 2x. Okay? Now, what about the derivative? As you can see, we have to get the derivative of our f function, or our f function. So what is the derivative? We have to get it again. So let's try to have our f of x. Okay? Our f of x is actually this one. So that is the same as 2x raised to 4 minus 3. Now we are now ready to get the derivative. So what is the derivative? The derivative now would be f prime of x. And so what are we going to do? Notice that we have in here 2x. Okay. Now in here that would be our multiplier. So 4 4 multiplied by 2x, okay? 2x, and that is the same as 4, in here the 4, minus 1. And what did we say about the derivative of a constant? We said that that must be 0, okay? So notice in here, we can have now a derivative of the f function. So what is the derivative? F, okay, prime of x would be, that is the same as multiply, so that is the same as 8, x raised to 3, minus 0, and so the final result would be f prime of x is equivalent to 8x raised to 3. Now, having said this one, okay, we're now going to apply. Okay, apply the multiplication. We multiply to the original function, and after that one we have. And so, how is that? Okay, let's try to have. Okay, let's try to have product of the sum. So we have in here. In here now, we say f prime. Okay, f prime or y prime is the same as what is our f. Okay, so our f is 1. So we have in here the quantity 2x raised to 4 minus 3. Okay, multiplied with the g prime of x. What is the g prime of x? So we have in here that is the same as g prime of x is the same as 2x. So multiplied by 2x. Okay, multiplied by 2x. Now again, in our equation, that is plus. Okay, so plus. Now it says in here, what is the original g function? Our g function is the quantity x raised to 2 plus 1. And it says in here, multiplied with the derivative of the f function, which is the same as f prime of x multiplied by f prime of x is equal to 8x raised to 3. So we multiply that one, so it will give you 8x raised to 3. Okay? So having said that now, we're now ready to multiply. So that is to be multiplied. Y prime is the same as 2 multiplied by 2. That is the same as 4x raised to 5. Okay? And that is the same as minus 6x. Okay? 6x. And what about this one? Let's try to multiply. Multiply this one. That is the same as 8 plus 8x. Okay, what about the exponent? That is the same as 5. And what about this one? That is the same as plus 8x raised to 3. Okay, so notice that we try to distribute this one. Okay, multiply. Okay, so again in here we multiply it in here. That is the same as Now, having said that one, that's the time we're going to combine now the similar terms. So what will be the similar terms? So we have now y prime is equal to, as you can see this one, they are about the same. Okay, they have a literal coefficient of x raised to 5, x raised to 5, and so that can be said to be 12x raised to 5. Okay. Now notice that we cannot add this one, so we just say that is plus 8x raised to 3, and then minus 6x. So that will be now, this will be now the, okay, this will be now the final answer or the derivative of this problem. Okay, so that will be now the derivative of this problem. Okay. What about the second one? Let's try to see the second. Okay. Notice again that we have to identify. If we are going to identify, our second problem is y is equal to the product of the quantity x raised to 2 plus 4x plus, this must be 4. Okay. This must be 4. Okay. Let's try to have this one to be 4. Okay, so multiplied by the quantity x raised to 3 minus 2. So how are you going to do that one? Again, identify our f. So our f is in here. Okay, that must be our f, and that must be our g of x. Okay. Now again, we do the same. Okay, we do the same. We try to get the f function or g function and then get the derivative. So our g function, okay, our g function, g of x is actually x raised to 3 minus 2. Now what is the derivative? Okay, what is the derivative? We say the derivative is g prime of x. So how's that? That is the same as, let's try to do this one to be the numerical coefficient. That is the same as 3x. And so for the exponent of x, you minus 1 in here. Okay, so 3 minus 1, that is the same as 2. Okay, what about the derivative of the constant? We say that that is 0. So our derivative now is g prime of x is the same as 3x raised to 2. So that is the derivative of our g function. Okay? Now let's try to have the derivative of our f function. So for our f function, we say, okay, f of x is equal to, that is the same as x raised to 2 plus 4x plus 4. Now what would be the derivative? Now let's try to have f prime of x is the same as, how's that? Bring it in here. So that would be the numerical coefficient. So we have 2x. And then what about the exponent of this one? That is the same as minus 1. 2 minus 1 is the same as 1. And so what about this one? That is the same as 4, okay? 4. So what is the exponent of x? 1 multiplied by 4, that is the same as 4. And so x raised to 1 minus 1, it will be 0. X raised to 0 is the same as 1. 1 multiplied by 4, that is the same as 1. Now what did we say about the derivative of the constant? That is the same as to be plus 0, okay? Now what would be now the derivative? So the derivative now of f function is f prime of x will be 2x, okay, plus 4. So that would be our derivative, okay. Now having said this one, we can now apply this equation. So how is that? How is our equation? It says in here, okay, the derivative of your y is y prime. So y prime is equal to, what is that? F function, the original f function. What is the original f function? We have in here. Okay, the quantity x raised to 2 plus 4x plus 4. Okay, multiplied by the derivative of the g function. The derivative of the g function is we have in here, multiplied by 3x raised to 2. That is the same as 3x raised to 2. Okay. Now it says in here plus, okay, plus, what is that? Original g of x. So what is the g of x? Our g of x now in here is the quantity x raised to 3 minus 2, multiplied by the derivative of the f function. What is the derivative of the function? That is, we have in here 2x plus 4, okay? Now, having said that one, that's the time we're going to multiply. Okay, multiply and then add. So it says in here, we're going to distribute. Okay? Okay, so that if we will be distributing that one, this one is 3x raised to 2 multiplied by x raised to 2, it will give you 3x raised to 4. 3x raised to 2 multiplied by 4x plus 12x raised to 3. Okay, what about this one? That is the same as plus 12x raised to 2. Okay, x raised to 2. Now, how about this next? Before that, we have to expand. We have to multiply. So, if if we multiply, this one is the same as x raised to 3 multiplied by 2x. We have 2x raised to 4. Okay, 2x raised to 4. Now what about this one? It will give you now that is the same as plus 4x raised to 3. How about this one? It will give you minus, okay, minus 4x. And what about this one? It will give you that is the same as plus 8. Okay, plus 8. Now, after expanding them, that's the time we're going to combine the similar terms. Okay? So, for the similar terms, let's try to add f prime. So, we have in here 3x raised to 4. Do we still have in here? Yes, we have in here. So, that is 5x raised to 4. So, we have in here 5x raised to 4. Now, what about this one? 12x raised to 3. We have x raised to 3. Yes, we have in here 4x raised to 3. So 4 multiplied by 12, that is plus 16. X raised to 3. Now, what about this one? 12x raised to 2. So as you can see, we do not have. So that is the same as plus 12x raised to 2. Okay, so the next thing that we're going to look into now is we have it here. So that is the same as minus. That is the same as minus 4x. Okay, minus 4x. And then that is the same as plus 8. So meaning, we have already combined them. And so our final answer now, okay, is the one that is being put in box. Our final answer is y prime of y prime is equal to 5x raised to 4 plus 16 x raised to 3 plus 12x raised to 2 minus 4 plus 8. Okay? Now, of course, before we're going to leave this one, we have to recheck. So let's try to recheck our addition or our multiplication. So that is the same as, okay, multiply. So that is the same as 4x raised to, if we multiply 2x raised to 4, multiply this one, that is the same as 4x raised to 3. Multiply this one, that is the same as 4x, negative 4x. That is the same as I said, okay. So this must be minus, okay. This must be minus, and this must be minus, okay. So that is how to see the problem, okay? That is how to see the problem. You always go over, especially if it involves an operation that is minus or negative, okay? So as you can see, when we are going to multiply this one, it will give you result of negative, okay? So after having said that one, that's the time we're going to combine similar terms. So we have in here, okay, 3x raised to 4, that is the same as 2x raised to 4, you want them, that is the same as 5x raised to 4. Now what about this one? Okay, this one, that is the same as 12, 16, okay, 16x raised to 3. Now what about this one? It is alone, walang kasama. And what about this one? No companion, that is the same as no companion. And so, combining them, okay, having said that one, that is the same as the result is this one. Y prime is equal to 5x raised to 4 plus 16x raised to 3 plus 12x raised to 2 minus 4x minus 8. Okay? So that is the number 2. Now, so that for the number 3, I think we do not have the space, so we have to bring it up. Okay? Let's try to bring it up. So our number 3, okay? Let's put the number 3 here. So we have y is equal to the quantity x, square root of x plus 2, okay, multiplied by this one, x raised to 3 plus 2x, okay. So yeah, we transfer it on top so that we have the space, okay. We have space. So notice that when we are going to do the problem, okay, this one, so that this we will be making use of the space. We will maximize the space. So that if you're going to have that problem, Meaning to say, again, you have to identify our f. Okay, our f is we have here, our g is we have here. Okay, so having said that one, let's try to get the derivative of each function involved. So what is the derivative of the first one? So we have in here f of x. Okay, f of x is equal to the square root of x plus 2. And so what would be the square root, or what would be its derivative? Convert this one to exponential form. So if we're going to convert that one to its exponential form, that is the same as the quantity x plus 2 raised to 1/2. After that one, that's the time we're going to get now the derivative. Okay? We're going to get the derivative. And so what would be the derivative? Let's try to make use of this color. So f prime of x, what would be our multiplier? 1/2. Okay? 1/2. The quantity x plus 2. Okay? The quantity x plus 2. And what about this one? 1/2 minus 1. Okay? 1/2 minus 1. And so what would be the derivative? The derivative now would be f prime of x is the same as 1/2, that is the quantity x plus 2 raised to negative. Okay, negative 1/2. 1/2 minus 1 is negative 1/2. Okay, negative 1/2. Now after that one, that's the time we're going to put this one into its positive form. Okay, so how do we put this one into its positive form? We say that that must be f prime of x is the same as 1/2. Okay, that is the same as 1/2 and 1/2. Now put this one into its in the denominator to make it positive. So the quantity x plus 2 raised to 1/2. It's already positive. Okay? It's already positive. Now after that one, you do it also in here. Okay? So what is the derivative of the other one? G of x. So our G of x is actually x raised to 3 plus 2x. What would be its derivative? The derivative is g of x, okay, is the same as 3x raised to 2. How about this 2x plus 2? So those are our derivative. Okay? So the derivative we have in here is m. Okay? So after having known the derivative of each one, that's the time we're going to apply now this one. Okay, we're going to apply. Okay, so we will apply our working equation. Okay, so if we're going to apply our working equation, we'll say now that y prime is equal to what is our f of x. Okay, what is our f of x? We have in here. So that is the square root of x plus 2 multiplied by the derivative of this one. What is the derivative? The derivative is the same as multiplied by 3x raised to 2 plus 2. Okay? Raised to 2 plus 2. Now, notice that when we're going to the other one, we say plus, okay? Plus, and then we follow again this one, okay? So let's try to do it. That is the same as, what is our original? Our original g of x is the same as g of x, our g of x is the same as x raised to 3 plus 2x, okay? And of course, multiplied by the derivative. What is the derivative? The derivative is 1 over 2 multiplied by x plus 2 raised to 1/2. Okay? Now, after that, that's the time we're going to multiply them. So notice that when we are going to multiply this one, so what are you going to do? You put this one into its form that is the same as we have in here, okay? Fractional form, we might be doing that one, okay? So that is the same as y, okay? Y prime is, what is that? That is actually the quantity, okay? The quantity x plus 2 raised to 1/2, okay? Raised to 1/2. And of course, multiplied by, that is the same as 3x raised to 2 plus 2. And so, now what about this one? Okay, that will be plus. You can directly multiply the numerator to this one. Okay, so that is the same as plus x raised to 3, x raised to 3 plus 1 multiplied by this one. That is x plus 2 over, okay, over, that is the same as 2 multiplied by x plus 2 raised to 1/2. Okay, having said that one, we can put a final as our final answer. You can copy this one or this one by having this one. So we have in here, that is the same as, so let's try to have 3x, the quantity 3x raised to 2 plus 2 of the square root of x plus 2 plus, we have in here, that is x raised to 3 plus 2, put it in the radical symbol, that is 2, the square root of x plus 2. So we can have this one to be our, final result, okay? We can have this one to be our final result. Now you might be saying,